right, so here's an example out of the textbook. One of the homework problems, similar to the type of problem you're going to be asked to do. Essentially what you're asked to do is we're going to come up with the derivative at each of these 4 points using the most accurate formula available. Okay, now there's a couple formulas that I didn't give you in the book that I would like you to at least look in the text and refer to. There are 5-point formulas for the approximation of the derivative. Now in this example, because there are only 4 points, you can't use the 5-point formula. So the best we can do is one of our 3-point formulas. When you're at a table like this and you have the first point, next point after that, next point after that, I want you to notice that they're all equally spaced. For the first one, you would have to use one of the end-point formulas or the forward difference formula, right? This one, you have a choice of either doing the forward because you have this point and then 2 after it, so that's a 3-point option. But the more accurate formula, as I just told you, because the error was in half of the other 2, would be to use the midpoint or the central difference 3-point formula, which uses the point before it and the point after it. So I would use a different formula for the first one than I would for the second and third one. And then I got to go back and use the endpoint formula again, or the backwards difference in this case, for the last one to approximate what the derivative for each one of these would be. Okay? So I can find the derivative as accurately as my formulas will let me. If I had 5 points, that's when I would look up the 5-point formula in the book and use one of those. Okay? So for this 7.4, we're going to use the forward difference formula, the endpoint, or forward difference, which looks like this. F prime at x naught is 1 over h, okay, times, and I don't have these memorized and don't expect you to memorize them either, but it's negative 3 halves f at x naught plus 2 at f of x1 minus 1 half at f of x2. So this is now 1 over, and h in this case is clearly 0.2 because that's the step size. 1 over 0.2 times negative 3 halves times negative 68.3193 plus 2 times negative 71 times 6982 minus 1 half times a negative 75.1576. And I'll go to my calculator. I'll probably cut this part out of the video and get straight to the answer, but I'm not going to walk to the camera. 0.2 divided 3 under 2 divide negative 68.3193 negative times 2 enter 71.6982 negative times plus 0.5 negative 75.1576. Ah, crud. Here we go, 0.5 times 75.1576 negative times plus times, and I get negative 16.69325. All right, to do f prime at x1, I'm going to use the midpoint or central difference 3-point formula, which is 1 over h times negative 1 half f at the point before it plus 1 half f at the point after it. Okay, these are approximate. I should probably be clear about that. So that gives me 1 over 0.2 times negative 1 half at negative 68.3193 plus 1 half times negative 75.1576. Okay, so we're here and we're using the point before it and the point after it. So let's go to the calculator. 1 enter, 0.2 divides 5, 0.5 negative 68.3193 negative times 0.5 enter 75.1576 negative times plus times is a negative 17.09575. And I think you get the idea. This one's going to be the same exact formula, only I'll use this point and this point. So I'm going to skip over that, and let's do f of x, the prime at x3. Just kind of see how I adapt the formula. Remember that the formula was something to the effect of a positive 1/2, a -2, and a positive 3/2. But it was, if I'm going to do from x3, or from this 8.0, I'm going to do that point and the previous 2. And so I start here and work my way towards this one. So it's still 1 over 0.2. It's going to be, it's 1/2 times f at 2 points before this. So f at x1 minus 2 at f of x2 plus 3/2 at f of x3, where I am. Okay? So 1 over 0.2 times 1/2 times negative 71.6982 minus 2 times negative 75.1576 plus 3/2 times negative 78.6974. And to the calculator we go. 1.2 divide 0.5, 71.6982 negative times 2. Enter 75.1576 negative times minus 3 and 2 divide 78.6974 negative times plus times is negative 17.9. And again, the only reason I left this one out is because the process is the same as this one, so you should be able to do this one with these 2 points. But that's how we would do a problem where we use our best formulas. Now, some of the other problems will involve using your error terms, and you can certainly come ask me some of those questions, maybe even ask me in class, and I'll talk a little bit about them there. But that's all I wanted to show you for today, and now you can go ahead and start the homework for 4.1.